To obtain the estimate of beta, we say from equation star differentiate with respect to beta. If we differentiate with respect to beta, so we'll write it as the log of the likelihood function of the Laplace distribution all over beta to be equal to now. We differentiate the whole of this. If you differentiate the whole of this, since there is no value for beta here, we make it as zero, it turns to zero. It becomes negative zero. This, if there is a value for beta here, it becomes, if you differentiate the whole of this, it becomes negative n all over beta. If you differentiate the whole of this with respect to beta, you get negative, we already have negative sign, negative 1 all over beta squared summation of xi minus mu. So this is what we get. It then means that if we want to write this properly, we'll have our log likelihood function of x mu beta all over the beta is equal to negative n all over beta plus summation of xi minus mu all over beta squared. So this is what we get. The next thing to do is to equate the whole of this to zero. We also move over to the other side of the ball. So we equate the whole of this to zero to maximize beta. I will also do it here. So write equates to zero. We are equating the whole of this to zero. We have negative n all over b plus summation of xi minus mu all over beta squared is equal to zero. Of course, this can move over to the other side to give us negative n all over beta to be equal to negative summation of xi minus mu all over beta squared. So this can cancel this. This will come over here to give us beta squared all over beta to be equal to summation of xi minus mu all over n. So this can cancel this. It then means that our beta estimate will be equal to summation of xi minus mu all over n, as I running from 1 to n. So this becomes our estimate for beta, while this here becomes our estimate for the mean, and this becomes our estimate for beta. Remember, this is our scale parameter, while the mean is the location parameter. So this is how to obtain the maximum likelihood estimation for the Laplace distribution. For more on this topic, you need to subscribe to this channel.